Hello student, I am Latif sir. Today I will discuss about the first chapter of ICSE class 9 chemistry, the language of chemistry. The topic is the language of chemistry. Let's start. In this chapter, first we will learn what is symbol. What is a chemical symbol? A chemical symbol is is the short form that stand for the atom of a specific element. That is, a symbol is the short form that stands for the atom of a specific element. Initially, Dalton used some type of symbol to represent element, such as a circle for an oxygen atom and a circle with a dot in its center for a hydrogen atom. Later, John Berzelius suggested that the initial letter of an atom written in capital should represent that particular element. For example, O for oxygen, H for hydrogen, C for carbon. However, when the first letter of more than one element is the same, the elements are denoted by two letters. The first letter is written in capital while the second one is written in small. For example, you can see here carbon, cobalt, and copper all are uh, all in all cases the first letter start with C. Huh. That's why only C is used for carbon, but CO is used for cobalt, and Cu is used for copper, where Cu taken from its Latin name cuprum, symbol of some common element. Here you can see symbol of some common element. Symbol name of the name in English symbol. So hydrogen symbol is H, oxygen symbol is O, nitrogen symbol is N, fluorine symbol is F, chlorine symbol is Cl. Okay, iodine symbol is I, carbon C, sulfur S, boron B, silicon Si, arsenic As, helium He, aluminium Al, magnesium Mg, calcium Ca, argon Ar, neon Ne, nickel Ni, zinc Zn, uranium U, radium Ra, manganese Mn, chromium Cr. Sometimes symbol are some elements symbolized according to their Latin name. So symbol of certain element based on their Latin name. For example, name of the element, symbol and Latin name. In the box you can see gold symbol is Au. It taken from its Latin name aurum, Aurum. You can see silver symbol is Ag, taken from Latin name argentum. Similarly, mercury Asg, hydra hydrargyrum, copper Cu, cuprum, lead Pb, plumbum, iron Fe, ferrum, sodium Na, natrium, potassium Ka, Latin name is Kalium, tin symbol is Sn, and Latin name stannum. Now, significance of a symbol. Symbol is represent the name of the element. Second point, one atom of the element and atomic mass of the element. So these are the significance of symbol. Now valency. What is valency? Valency is the combining capacity of an atom. Valency is the combining capacity of an atom. The valency of an element or of a radical is the number of hydrogen atom. Valency of an element or of a radical Valency of an element or of a radical is the number of hydrogen atom that will combine with or displace one atom of that element or radical. Here you have to remember a point. Since no other element has combining capacity less than that of hydrogen, its valency, that is valency of hydrogen, is taken to be 1, and it's considered as standard. Okay. For example, in HCl, chlorine atom is attached with one hydrogen. That's why valency of chlorine is 1. In water, H2O, oxygen is attached to two hydrogen atom. That's why valency of oxygen is 2. In case of ammonia, NH3, valency of nitrogen 3. In case of methane, CH4, one carbon attached to four hydrogen atom. That and thus valency of carbon atom is 4. Now, modern definition of valency. According to the modern definition, the number of electrons that atom can lose or gain or share during a chemical reaction is called its valency. Number of electrons that an atom can lose, gain, or share during a chemical reaction is called its valency. Now here some notes is given. Notes are given. You have to remember these notes. The outermost shell of an atom is called valence shell. The outermost shell of an atom is called valence shell. The electron in the valence shell are known as valence electron. The electrons in the valence shell are known as valence electron. Next point, elements with 1, 2 or 3 electrons in their valence shell are usually metal. So which elements are metal? The elements with 1, 2 or 3 electrons in their valence shell are usually metal. Next point, elements with 5, 6 or 7 electrons in their outermost shell are normally non-metal. You have to remember. Elements with 5, 6 or 7 electrons in their outermost shell are normally non-metals. And the last point, stable electronic configuration is that which contain 8 electrons in the valence shell. Stable electronic configuration is that in which 8 electrons are present in the valence shell. Now, see, thus, to attain stable electronic configuration, metal atom lose electron from their valence shell, forming cation. Because metal have 1, 2, or 3 valence electron, thus they want to get stabilized by attaining 8 electrons in their valence shell. That's why they easily release 1, 2, or 3 electrons to form cation. Because this is easy to release 1, 2, or 4, 1, 2, or 3 electron. It is easy to donate or release rather than to accept 5, accept 7, 6, or 5 electrons. Okay, that's why metals form cation. Similar, for example, sodium has electronic configuration 281. It releases one electron, forming Na plus, and the electronic configuration is 28. This is more stable in thus Na plus is more stable than Na, because in Na plus, the in the valence shell there are total 8 electrons are present. Okay, and we know that if there is 8 electron present in the valence shell, then the electronic configuration, that is the ions, are more stable. Similarly, magnesium has electronic configuration 282. It releases 2 electrons, forming Mg2 plus bivalent cation. Mg2 plus is also more stable than Mg, because in Mg2 plus there are 8 electrons in the valence shell. Similarly, in case of non-metal, there are 5, 6 or 7 electrons. That's why to attain stable electronic configuration, they accept some electron, okay, forming anion. Thus, to attain stable electronic configuration, non-metal atom gain electron forming an anion. For example, in Cl, electronic configuration is 287. It accepts one electron forming Cl minus. uni negative anion. Okay. So electronic configuration of Cl minus is 288, but electronic configuration of Cl is 287. Huh. That's why as there is 8 electron in the valence shell of Cl minus, that's why Cl minus is more stable than Cl. Similarly, oxygen, in case of oxygen, the electronic configuration of oxygen is 2,6. After taking or after gaining 2 electron, it becomes O2 minus. In O2 minus, there is total 8 electron in the valences, so O2 minus is more stable than O. Now here a box is given. See the box. Number of electrons in the outermost shell and valency. If number of electrons is 1 in the valence shell, then valency is 1 because it will release 1 electron rather than to accept 7 electron. It is easy to release 1 electron rather than to accept 7 electron. Okay, similarly, if 2 electron in the valence shell, then valence is 2. If 3 electron, then valence is 3. If 4 electron, valence is 4. But if 5 electron, valence is 3. Because when 5 electron are there, it is easy to accept 3 electron more to, to become 8 electron in the valence shell. Okay, rather than to lose 5 electrons. Similarly, in case when 6 electron are there, then it will accept 2 electron more rather than to because this is easy, rather than to release 6 electron. That's why valency is 2. In when 7 electron are there, it will accept 1 electron more, so valence is 1. When 8 electron are there, then valence is 0. Now variable valencies. What is variable valency? Certain element exhibit more than one valency. That is, they show variable valency. For example, Fe, iron, Fe. If we have two valencies, Fe2 plus and Fe3 plus. Uh, that is that is iron, copper, uh, copper, tin. This element can show more than one valency. That is, they show variable valencies. What is the reason for variable valency? An atom of an element can sometimes lose more electrons than are present in its valence shell. An atom of an element can sometimes lose more electrons than are present in its valence shell. That is, there is a loss of electron from the penultimate shell too. Therefore, such element is said to exhibit more variable valency. See the next one, if an element exhibit two different positive valencies, if an element exhibit two different pos vari two different positive valencies, then we use the suffix ic for the higher valencies, and we use the suffix as for the lower valency. For example, Fe has two valency, Fe3 plus and Fe2 plus. And in case of 3 plus, we use ic, that is ferric, and in case of Fe2 plus, we use as, so ferrous. The name of the Fe2 plus is ion is ferrous, and name of the Fe3 plus ion is ferric. Some example of variable valencies. Fe has two valency 2 and 3, that is Fe2 plus ferrous and Fe3 plus ferric. Copper shows two valencies 1 and 2, so Cu plus, that is Cu plus, and Cu2 plus, that is cupric. Similarly, mercury shows two valencies 1 and 2. In mercury plus 1, it is written the formula of mercury in Hg plus. It is not actually written Hg plus, this is actually written that Hg2 2 plus, that is for each Hg the charge is plus 1. So mercurous means Hg2 2 plus, and mercuric means Hg2 plus.